The IUPAC is the International Union of Pure and Applied Chemistry. It is an international scientific organization, not affiliated with any government. The IUPAC strives to advance chemistry, in part by setting global standards for names, symbols, and units. From the beginning, the organization has sought international cooperation between chemists. In addition to setting guidelines, the IUPAC sometimes helps to resolve disputes. An example is the decision to use the name sulfur instead of both sulfur and sulfur. In order to name organic compounds, you must first memorize a few basic names. These names are listed within the discussion of naming alkynes. In general, the base part of the name reflects the number of carbons in what you have assigned to be the parent chain. The suffix of the name reflects the type or types of functional group or groups which represent on or within the parent chain. Other groups which are attached to the parent chain are called substituents. Alkanes are of great importance to the different classification systems and the naming of organic compounds, because they consist of a carbon chain that forms the main structural unit of all organic substances. Hydrocarbons are compounds of hydrogen and carbon. Below ordinary circumstances, some of the hydrocarbons are gases, others are liquids, and still others are solids. The most common is also the smallest, methane. Propane, kerosene, gasoline, lubricating oils, paraffin, and Vaseline are all hydrocarbons.
Hydrocarbons are compounds made of hydrogen and carbon, and they are classified in four. Alkanes that contain only carbon-carbon single bonds, alkanes that contain a single carbon-carbon double bond, alkenes that contain a single carbon-carbon triple bond, and aromatics that contain benzene rings and their derivatives.
More than 90% of the compounds in this world are organic compounds. Alkanes are the kinds of hydrocarbons that are connected with a single bond. Time ago, when they started to give the name to the alkanes, before they got the name from the person who discovered them or from the place that were being find them. But when the things were passing and they were watching that there were a lot of alkanes, they just started to give it a specific classification. So they start to having like number names like hectane, pentane, octane, just in order that they were find them and that things. There are three ways to write a structural formula. The first one, that is the expanded structural formula, the second one, that is the condensed structural formula, and the third one, that is the skeletal formula. There are the three ways. One is more expanded than the other. This one is more condensed, more smaller, and the skeletal, that is the one that is drawn.
Hi, I'm gonna make a tutorial for alkenes. Alkenes are a family of hydrocarbon compounds containing carbon and hydrogen only. Containing a carbon-carbon double bond, you can work out the formula of any of them using CnH2n. Alkenes are named for their parent alkane, changed with the suffix "n", and an infixed number indicating the position of the double bond carbon in the chain. CH2 double bond CH, CH2, CH2 is both slide 1, slide n. Multiple double bonds take the form Dn, 3n, etc. With the size prefix of the chains taking an extra A, CH2 double bond CH, CH double bond CH2 is Buddha slide 1, 3 slide Dn. It is IUPAC convention to describe all alkenes using absolute descriptors of C slide same side and E slide opposite, with the chain in gold priority rules. These are some steps the easiest to determine the name of an alkane. First, count to find the longest continuous chain of carbon atom that contains the multiple bond. Number of carbons by giving the multiple bond the lowest possible number. Second, list a number the alkyl group present a sign-latin prefix if necessary. List them alphabetically. For the purpose of alphabetizing, ignore the prefix D3 etc. 3. Write the name using proper punctuation. Commas are used to separate numbers, and hyphens are used to separate numbers and letters. I'm gonna give some 3 examples of alkanes that we have the formula and I give the name. We have these 3 examples. The first one is C2H4. We have 2 carbons with 1 double bond and 4 hydrogens. We know that the double bond says that the suffix is in, and with the two carbons we have that the prefix is eth, and by joining these two prefix and suffix we have the name of this structural formula that is attained. Then we have this example that is C3H6. We have 3 carbons, 1 with double bond and 6 hydrogens. We know that with double bond we have the suffix n, and with these 3 carbons we have the prefix pro. By joining these two we have the name of this structural formula that is propane. We have this example that is C4H8. We have 4 carbons with 1 double bond and we have 8 hydrogens. By having a double bond we know that it finishes with N, and the prefix by having 4 carbon is but. By joining this we have butane. But if this double bond is in here, we need to count the carbons. We have 1, 2, and this is the double bond. We have that is a but slide 2 slide n. Okay. These examples we can know how to name the alkenes by the formula. Now I'm gonna talk about how to draw the alkenes with this formula. We have to translate the name of an alkene into a structural formula requires the same kind of systematic approach introduced in your study of alkanes. Decompose the name from right to left, beginning with the name of the parent chain, the location of the multiple bond, and then the locations of the alkyl groups. I'm gonna give 3 examples, and this is. The first example is how to draw a structural formula for 2 slide ethyl slide 1 slide pentane. We begin by drawing the parent chains including the multiple bond. We have 1 carbon, 2 carbon, the double bond is here, that's why we start from here. 3 carbon, 4 carbon, 5 carbon. Then add the alkyl group to the prepared carbon atom. An ethyl group is located on the carbon 2. We have the ethyl group in the carbon 2. First carbon to carbon. We have the ethyl group here. Then this is a structural formula, or we can use this structural formula. We have this example. We're gonna make a thin formula structure. We have C2H4. We have 2 carbons, 1 with double bond. We have 4 hydrogens, 1 hydrogen, 2 hydrogens, 3 hydrogens and 4 hydrogens. This is the structural formula for ethene. We have 2 carbons with double bond and we have the 4 hydrogens. We're gonna pass to the other example, that is propane. We have 3 carbons, 1, 2, and the third with double bond. We have 6 hydrogens, 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen, 5 hydrogen, and 6 hydrogen. We know that these are hydrogens, and with the propane has 3 carbons. There are 3 carbons, 1 with double bond, and we draw 6 hydrogen. This is how we draw the structural formula.
So, what are alkynes? The alkynes are the third homologous series of organic compounds of hydrogen and carbon, where there is at least one triple bond between the atoms in the molecules. They conform to the general formula CnH2n-2 for one triple bond. The IUPAC rules for alkynes nomenclature. 1. The YNE suffix ending indicates an alkyne or cycloalkyne. 2. The longest chain chosen for the root name must include both carbons of the triple bond. 3. The root chain must be numbered from the end nearest a triple bond carbon atom. If the triple bond is in the center of the chain, the nearest substituting rule is used to determine the end where numbering starts. 4. The smaller of the two numbers designating the carbon atoms of the triple bond is used as the triple bond locator. 5. If the several multiple bonds are present, each must be assigned a locator number. Double bonds precede triple bonds in the UAPCA name, but the chain is numbered from the end nearest a multiple bond regardless of its nature. 6. Because the triple bond is linear, it can only be accumulated in rings larger than 10 carbons. In simple cycloalkynes, the triple bond carbons are assigned ring locations 1 and 2. Which of the two is 1 may be determined by the nearest substituting rule. 7. Substituting groups containing triple bonds are HC triple bond C, ethinyl group, HC triple bond CH, CH2 propargyl group. So here we have the first example for naming a compound. First, we need to identify the main chain of the compound, that is this, and then we need to start counting the carbons from the place that is nearest to the triple bond. That is from here, and we have 1, 2, 3, 4, and 5 carbons. So 5 carbons means that is a pentane. So the triple bond means that it will be a pentyne. So then we need to identify the methyl groups, and we only have one that is in the carbon number 4. So it will be 4-methyl. So finally the compound will have the name of 4-methyl 2-pentyne, because the pentyne is here in the second carbon. So here we have the second example for naming a compound. First, we need to identify the main chain, there is this, and then we can start counting the carbons. There are 1, 2, 3, 4, 5, 6, and 7, and we call it an heptane. Then we need to identify the methyl groups. There are 1, 2, and that is called dimethyl. So the methyl groups are located in the second carbon and in the fourth carbon. So we need to put 2, then comma, 4 dimethyl, then an hept for heptane,
then 3 in 5 ein, because these two are the location of the double, that is this, and the triple bond.
Drawing alkynes. As with alkenes, when drawing alkynes, 1. Draw the carbons for the parent chain and number the carbons and insert the triple bond. 2. Draw in the alkyl groups. 3. Fill in the hydrogen so every carbon has 4 bonds. A reminder that triple bond count as 3 bonds. 4. In your assignments, you will probably want to condense the structural formula at this point, putting the alkyl groups in brackets following the carbon to which it is attached. In the first example, you need to draw the structural formula for 1-butane. So the first step, you need to draw the carbons for the parent chain and number the carbons and insert the triple bond. The ending is YNE, so this is an alkyne. The parent chain is butane, 4 carbons. Triple bond goes on the first carbon, that is between carbons 1 and 2. Then the step 2, you need to draw in the alkyl groups, but there are no alkyl groups. Then the step 3, fill in the hydrogen so every carbon has 4 bonds. So in here we fill the hydrogens. Then the step 4, you need to condense for assignments, but this is sufficiently condensed. For the example 2, you need to draw the structural formula for 2,2,5,5-tetramethyl 3-hexane. So the first step, you need to draw the carbons for the parent chain and number the carbons and insert the triple bond here. Then the step 2, you need to draw in the alkyl groups. The tetramethyl indicates there are 4 methyl groups, 2 on the 2 carbon and 2 on the 5 carbon. Here is the 2 carbon and here is the 5 carbon. Then in the step 3, you need to fill in hydrogens so every carbon has 4 bonds. Then in the step 4, you need to condense for assignments. So the condensed structural formula for this will be this. In the final example, you need to draw the condensed structural diagram of this. So first, you need to draw the number of carbons, and you know that it is hept, so it will be 7 carbons. So here are the 7 carbons. So then you need to draw the methyl groups. So in here, because it is dimethyl, we know that there will be 2 methyl groups, and one is on the 4th carbon, that is here, and the other is in the 5 carbon, that is here. So then you need to fill the hydrogens that are left here. And
an aromatic compound is any compound that consists of a benzene ring or certain benzene-like properties, but not necessarily a strong aroma. You can recognize aromatic compounds by the presence of one or more benzene rings in their structure. In the International Union of Pure and Applied Chemistry System, aromatic hydrocarbons are named as derivatives of benzene. This means they are named with the group that replaces the hydrogen atom named as a substitute group, like chlorobenzene, bromobenzene, iodobenzene, nitrobenzene, or ethylbenzene. When there is more than one substance, the corners of hexagon are no longer equivalent, so we must designate their relative positions. When there are 3 possible substituents benzene, we can use numbers to distinguish them. Then we start numbering the carbon atom to which one of the groups is attached and count toward the carbon atom that bears to the other substance group by the shortest path. Like, we can say 1, 2 dichlorobenzene, 1, 3 dichlorobenzene, 1, 4 dichlorobenzene. we are saying like you are in the first carbon, then how many carbons you are away from the first carbon. If you see, there are only two chlorines in each molecule, but they are different because the position of it. Commonly names are used the prefix ortho for 1,2 distribution, meta for 1,3 distribution, and para for 1 to 4 distribution. In the examples that we already give, the first one to dichlorobenzene, we will say ortho dichlorobenzene, and the other will be 1,3 dichlorobenzene meta dichlorobenzene or 1,4 dichlorobenzene para dichlorobenzene. The substituent names are listed in alphabetical order. The first substituent is given by the lowest number. There are common names used. The carbon atom that bears the group response for the name is given the number 1. Well, an example could be 1 bromo 4 chlorobenzene or para bromo chlorobenzene. Another example could be ortho bromo pentanol. Another is bromo luenil. Another is meta chloroanilel. Well, for the structural formula is quite easy. All are based in a hexagon that are composed of carbons, and then they are attached hydrogens to one carbon of each. So when element substitute a carbon, there is why you put another name, but continues to be an aromatic compound. Okay, you could see a few examples.
Carbon derivatives are molecular compounds of carbon and at least one of other element that is not hydrogen.
Next, you will see a table with the most common functional groups. It shows the group formula, the class name, the example, the IUPAC name, and a common name. The first one is alkene. The example is CH2 equal to CH2, and the IUPAC name is ethene. The common name is ethylene. The second one is alkyne. The example is CH. The IUPAC name is ethene, and the common name is acetylene. The third one is arene. The example is C6H6. The IUPAC name is benzene, and the common name is benzene also. The fourth one is alcohol. The example is CH3OH. The IUPAC name is methanol, and the common name is wood alcohol. The last one is chloro. The example is CH3Cl. The IUPAC name is chloromethane, and the common name is methyl chloride.